Hi, and welcome along to the sixth video in our Container Security Fundamentals series. In the last couple of videos, we've been taking a look at Linux namespaces and how various different namespaces can help isolate a container or a Linux process from the underlying host. In this video, what we're going to do is we're going to move on and take a look at Linux capabilities and how they're used by both Docker and other processes inside Linux to try and limit the privileges that someone has. So to give you a little bit of background, traditionally in Linux, you essentially had two groups of users. You have the root user, and the root user is all privileged, has all rights on a host. And then we have ordinary users who don't have any root style high privileges. This means that if you wanted to do something that was part of those root privileges, you would need to use su or sudo to essentially make yourself run as root, or you would need to set a binary as being setuid root. Now, all of these solutions aren't very good because they're not very granular. It's kind of all or nothing. And obviously, sometimes you only need a small fraction of high privileges on a Linux host, not the whole thing. As a result of this, Linux has developed a thing called capabilities. And what capabilities do is they allow us to set a file or a process to have a small fraction of root's overall privileges without having to give all of them. At the moment, there are 41 different capabilities available within Linux. So there's a lot more flexibility there. So let's dive straight in with an example, and we're going to show you how this works. What we're going to do is we are going to, first we're going to actually use a container to demonstrate something. So if I do docker run -it ubuntu we'll do 2204, and we'll run bash shell inside this container. Now, when we were looking at namespaces in the previous videos, one of the things that we said was the time namespace isn't used in containers. So when you have the time inside a container, that's the same time as is on a host. And there's no ability to have a container with its own kind of control. And also, we can note here that we're running as the root user. So far, based on what we know, this means that we should be able to change the time inside our container because we're root and we're not namespaced. So let's try and do that. We're going to use this command here, and we're going to try and change the time inside our container. And it's going to say operation not permitted. We can't do that. And so the question is, well, if I'm root and this isn't namespaced, why doesn't that work? And the answer, unsurprisingly given the topic of our video, is capabilities. So let's dive a little bit in and see how capabilities work, and also why it was that we weren't able to change this time inside our container. So in order to look at capabilities on the host, without really looking at containers necessarily, we can use a set of existing Linux utilities. The first one we can use is PSCAP. So what PSCAP does is it shows you any process on the host which either has all of the capabilities available or some subset of them. And we can see here that capabilities are actually reasonably well used by things like systemd processes to provide certain rights and not all of root's privileges, which is kind of what they're intended for. So some things have all of them, and some things only have certain capabilities. So you can see, for example, systemd resolved here only has net raw. So that's a good example of how capabilities are used and how you can look at them. You can just use PSCAP and actually have a look at that. The other thing I mentioned is that you can give capabilities to a file. So you can say, in the same way as we used to set setuid root on a file to say this program, whoever can run it, has all of the rights of roots. We can also do the same thing with capabilities, and we can say anyone who runs this program, who has rights to do that, has these capabilities when they run that program. If we want to look into that, we use another utility called FileCAP. And what we can do here is we can just run this command here, and this is going to go through all of our file system looking for files which have capabilities assigned to them. This bit at the end, just in case you're wondering what I'm doing with this just sends any errors to dev null, so it makes our output a little bit cleaner. So when we do that, we can see how all different binaries have been given certain capabilities. An interesting one that we can see come up here as it searches through is ping. So here we've got the ping utility from Snap, and it has the net raw capability assigned to it. Now this is because ping wants to create ICMP network packets. So ping packets are typically a thing called ICMP. And in order to create ICMP packets in Linux, you have to have the net raw capability. So instead of doing what we used to do in kind of older Linuxes, where ping would be set UID root, now we can just say you only get the net raw capability. So that essentially is quite a nice least privilege way of handling things. So that gives us an idea of how you can find capabilities. You can look and see what processes or what files are making use of this new facility. But obviously we want to talk a little bit about containers here. We want to talk a bit about Docker. So let's talk and look at how Docker handles containers with privileges. To do that, what we're going to do is we're going to do docker run -d nginx. So we're just going to run a standard Docker container with no special flags or modifications, and we'll have that running in the background. Now what we can do is we can use our PSCAP facility again, and we can grep for nginx. So if you remember back to one of the earliest videos in this series, one of the things we said is containers are just processes. So we can use this PSCAP utility, which is designed to interact with processes, to work on our container. So we'll say PSCAP will grep for nginx to show us any instances of nginx which have got capabilities assigned to them. So what it comes back with is this. Here is our nginx process, which is our container, and here are the capabilities that it was assigned. So we can see there is a set of capabilities that have been assigned. Now this is decided by the Docker project. So when Docker runs any new container, it has a default set of capabilities that are assigned to it. This set was decided to essentially try and allow as many containerized workflows to run without problems, without allowing for privilege escalation. Because there are some of the more highly privileged capabilities that if you give a user that capability, it's quite easy for them to escalate their privileges up to root. And the idea of the set that Docker provided was to let you do your work without allowing for that privilege escalation. So that gives us an idea of how these things work and how they work with Docker. The next thing that we want to talk about is, of course, how to harden it. Because we've got this set of default capabilities, but we want to try and reduce that down and actually say, that's the default, let's try and improve the security. And that's what we're going to do in our next video. So if you want to come back then, what we'll do is we'll dive into capabilities some more and look at how we can lock things down. If you need any more details on this kind of stuff, you'll find lots of blog posts on our Security Lab site covering all of this and more. I hope that was useful, and I look forward to seeing you in the next video.